scalene triangle. None of the sides are equal. That ratio tells it. Number 9. In triangle JLK, shown in figure 2, line JP is A, median, B, hypotenuse, C, base, D, altitude. The answer is D. The answer is D. The altitude, that's the height of the triangle. Number 10. How many faces has a tetrahedron? A tetrahedron is simply another name for square base prism. It has 6 sides. The answer is C. It has 6 sides. The answer is C. Number 11. Number 11. A line within a circle and touching 2 points on the circumference without passing through the center of the circle is A and A, radius, B, chord, C, arc, D, tangent. The correct answer here is chord. Chord is like diameter. The diameter passes through the center of the circle, while chord does not. So chord is the correct answer, which is B. Question number 12. Question number 12. The application of tangency of circle and lines is found in, this is principle of tangency question. A, fan blade. B, boiling ring. C, an electric bulb. D, a switch. This question can be deceptive, but if you look at the things provided, which is circle and lines, you will see that all of these drawings require lines of any type, but there is one that needs lines very much well, and that is bulb. So that needs circle very much well, and that is bulb. So the answer is C. All right, the answer is C. Question number 13 and number 14 are contained in the video shown below. The construction, number 13. Number 13. The construction shown in figure 3 will produce A. Now, what is it in figure 3? You have this line and this line. You can see it there in the question. 2 lines were intersected. You have a line like this and this one. Then there is a line that comes like this. They also cross each other. They are bisected, bisected. They are bisected and are bisected. This is the point. You only draw 2 lines to make it sound as if it's something straight. This is incomplete triangle, so they should be like this. And then they call it K, L, and J. It is only circumscription that can be done. Inscription requires that you bisect angle, at least 2 of the angle, either you bisect here and here, or here and here, or here and here. The lines to meet. You inscribe the circle inside the circle. Inside the triangle is called inscription. Inscribe. But here, they mention inscription. This is not for inscription. This bisection, when you bisect 2 sides, at least 2 sides of the triangle, you do what is called circumscription. The circle that is going to be produced will pass through this place, touching them from eyes. In other words, to put the triangle inside the circle called inscription. And it's not mentioned, but they hide it. So the answer here will be C. Number 14. The locus of a point on the circumference of a circle as the circle rolls without slipping along a straight line is, now listen, it is cycloid. Cycloid. And that is something we have always done from SS1. We have taught this one, where a circle is drawn. We divide the circle into like 12 equal parts. And then we draw like this. At the end, we produce a curve that goes like this. Alright? And then we draw so many circles. 12 other ones, making them 13. We produce this particular locus of a point starting. It is only a cycloid that can do that. Question number 15. It says figure 4 shows the construction of a parabola. Use it to answer questions 15 and 16. So you have to use this question to answer some 15 and 16. The path, level T, is A, an axis, B, a directrix, C, a focus, D, a vertex. The correct answer here is D, a vertex. T is the maximum point where parabola reaches and turns as it curves to form the curve. Now, number 16, if F is 15, then E is, now look at the drawing, you see F and E. The eccentricity of a parabola is 1. That means the distance from the directrix, which is YY, to the circumference of the parabola, which is the curve, and then from the circumference of the parabola to the focus, they are the same. So the answer here will be C. The answer in this case will be C. Now, question number 17. We are given two similar triangles, and it says two triangles shown in figure 15 are similar. Use them to answer questions 17 and 18. So question 17 goes like this. The two sides similar to each other are, now look at the options. A, R, S and MN. B, R, S and MY. C, T, S and MY. D, RT and MY. In this case, the correct answer is RS and NY. They are the next longest side that are connected to the shortest side and the hypotenuse, or the longer side. They are equal. The answer is C. Number 18. The two angles similar to each other are, we have T and N, B, T and Y, we have C, R and N, and then we have D, R and Y. Now, the correct answer in this particular place is what? R and N. It is the angle joining the shortest side and the second longest line. Now, questions number 19, 20, 21, and 22 are contained in the video shown below. Number 19, the isometric views of the object shown is, now the objects are shown above the two faces. All you need to do is do a sketch. If you know how to convert orthographic to isometric and oblique, this question should not be a problem to you. So the one to your left hand side, just draw it this way, and it's going to be like this. We put it this particular way, we've got this face down. Alright, this face is now out. The one to your right hand side will help you to complete it here. That dash line tells us there's a hole that goes inside. That's a dash line. The second dash line will help us that there is a hole that goes inside like this. So this one is it. And then you can complete your shape of this nature. So this is the object. From here you can know that A is the answer. Number 20. You see that the oblique form is nothing but adjust this one in such a manner that the angle here is now going to be 45, while here will be horizontal. So for that reason, it's going to be like this. The angle here is expected to be in this manner. So this is the oblique form of this particular object. You send it this way. Alright? And then this shape comes up like that. This is it, so you have something of this nature. Alright, so the oblique form of this is going to be D. Alright, that is what we have in this place. Alright, that's the case with apply. Now number 21, because we're using this particular diagram in figure 6 to answer 3 questions. Alright, number 21, the plan is shown in
A plan meaning you look at this object from the top, and that is from the top here. From the way they put it, that means this is where you're going to stand and look at this object from the plan. So you are going to take note of the hidden aspect. Of course, you will see these two places. They are already available there, and you can see that in A is available there, A and B. But what cancels B, A and C, sorry. What cancels C is that while this line here runs the same direction with this place, they put the other one across. The answer here, therefore, is going to become A. Question 22. Figure 7 shows two unequal square prisms. Say the line of intersection is A. We have A, B, C, and D. The answer is A. The answer is not B. The reason why it is not B is because this line did not touch here. Had it been this line reached this point, like this, we will say the answer is B. But it is A, so that means it stops somewhere, halfway this way, to bring this one like this. From here, you have a line to help us get this. Had it been touched here, we can say it is what? B. So be careful with these observations. The answer is B. Sorry, the answer is A and not B. The answer is A and not B.
Now question 23. The diagram, 23, figure 8 is drawn in isometric. To draw it in oblique cavalier, the dimension y on the receding side is cavalier drawing. It's a type of drawing that demands that you draw the object in an oblique, but